Hello students, let us see this question. Okay, the two coils P and Q are placed coaxially and it carries current. It is given, it is carry CA right, it carry current I and I dash respectively. So let us take two coils are here. Right, P current carry I. So here I will write here I. Okay, and the Q carry current I dash. So let us take this is I dash here respectively. Now it is saying the options. So four options are given. So let us see which option is correct here. If it is saying if I dash is equal to 0, so if I take according to the option 1, so it is saying I dash is equal to 0. So let us remove it. So I am removing this I dash. Okay. So I dash is equal to 0 and the P move towards Q. So assume this P is moving towards Q. Okay. A current in the same direction as I is induced. Okay, so let us assume the current flows in this direction. Okay, and this is moving in this direction and this is fixed. So obviously some induced current will be there in Q. I need to find the direction of induced current in Q. So obviously due to the Lenz law there will be some opposition to the P coil. So since the current is moving in this direction, so this will become north pole and this will become south pole. So if you want to oppose the moment of the P, then obviously if this side is south pole, so obviously this side should also be this side should also be south pole only. Then only the repulsion will be there, and then only the opposition can happen, and the Lenz law will be satisfied. So if this is the south pole, so obviously this will become north pole, and right, if the north pole is in this direction, so obviously due to the right hand rule I can say the current in this will go in this direction. So this will be the direction of induced current. So you can easily see the induced current direction is opposite to this current I. So option A is saying same direction. See, a current is in the same direction as induced, so obviously the option A is wrong. Okay, so let us go and try to check the option B now. So B is saying if I is equal to 0. So let us work in this only. So it is saying the I is equal to 0. So this I will remove here. And okay, I dash will be there then. If I is 0, then I dash must be there. Okay, and the Q moves towards P. So this time Q is moving towards P. So this Q is moving towards P. Okay, a current opposite in the direction to that of I dash induced in K. Obviously you can write, so option B seems to be correct. So let us check now. So suppose I dash moving in this direction and the current will be induced. Okay, so this I need to remove here. So this is the situation given initially. Suppose so now the P is fixed and the Q is moving. It is saying the Q moves towards P. So let us assume the current in Q is moving in this direction. So from the right hand rule I can say the north will go in this direction. So this face will behave like north pole and this side will behave like south pole. So obviously due to the Lenz law there will be some opposition, then only the current can be induced. If there is no opposition, then no current will be induced. So obviously there must be some opposition due to the Lenz law. So if this face is a south pole, so obviously in order to oppose this south pole, this face must also be south. Then only the repulsion can happen. And if this is south, then this must be north. So if suppose this is a north pole, so then obviously due to the right hand rule, this will become, so the current induced should be in this direction. Then only this face can be the north pole. So now you can easily see the induced current is in the opposite direction to the I dash. So let us see the option here. It is saying a current opposite to, right, a current opposite in the direction to that of I dash is induced in P. So obviously option B is coming correct here. Okay, now let us see. So since it is, so I can check option C also. When the I is not equal to 0 and I dash is not equal to 0 are in the same direction, then the two coils tends to move apart. So let us check this option also. So I can make another figure for this one. So let us see here. So this is the coil and this is the another coil. Okay, and now suppose this is P and I is flowing in this direction, in this one. This is Q and this is I dash, and it is saying both are I and I dash is not equal to 0, are in the same direction. So let us assume these are both are moving in the this direction only. Okay, now it is saying the coils tend to move apart. So let us see what will happen. So since the current is in this direction, so this will become north pole and this will become south pole. Here also the current is in this direction, so this will become north pole and this will become south pole. So now you can easily see the south and north are facing, so obviously they will attract each other. So the option is saying they tend to move apart, so obviously the option will C is incorrect. Okay students, I hope you understood this question.